Normally, to swap two variables, you use a third temporary variable to hold one while you move the other. But with XOR, we can swap two numbers using no extra storage at all. Let's swap 5 and 3 and see how the bits carry the values around. The magic rests on two facts about XOR. A value XORed with itself is 0, and a value XORed with 0 is unchanged. Start with equals XOR B. Now the first slot holds the mix of both. Next, B equals XOR B, which is XOR B all XORed with B again. The two B's cancel, so B becomes the original A. Finally, A equals XOR B, and since B is now the old A, the two old A's cancel, leaving A with the original B. The values have traded places, no temporary needed. First, it becomes XOR B, the combined value. Then B becomes XOR B, which cancels out the current B and recovers the original A. Then it becomes XOR B again, which recovers the original B. We return the swapped pair. Let's swap a couple of pairs and confirm they trade places. Fold both numbers together by putting XOR B into A. XOR out B to land the old A in B, then XOR out B again to land the old B in A. Return the pair now swapped without ever using a temporary. Now let's test it and hit run. Three and 5 come back as 5 and 3. 13 and 9 come back as 9 and 13. Perfectly swapped, and not one extra variable was used. 3 XOR operations, nothing more. Constant time and constant space, because we never allocated a helper variable to hold a value. One real warning. If both names point to the very same variable, the first XOR zeroes it out, and you lose the value. So this clever trick is mostly for learning. In everyday code, a simple swap with a temporary is clearer and just as quick.